Welcome to the live class. Refraction of light at curved surfaces. In that lesson, in last class, especially we discussed about the derivation of curved surface formula, that is n2 by v minus n1 by u is equals to n2 minus n1 by r. n2 by v minus n1 by u is equals to n2 minus n1 by r. That topic we discussed. So in this class, we are going to discuss about just extension. Here, n2 by v minus n1 by u equal to n2 minus n1 by r. Here, r is the radius of curvature of simply given a curved surface. Radius of curvature of a given surface. If that r is equals to infinity, what happens? For which surface we'll take that r is equal to infinity? Simple. Here, this curved surface formula also applicable for plane surfaces. How? Simply, we can change the radius of curvature value here. By changing that, you are able to apply this for curved surfaces. That we will discuss in this session. So here, is this curved surface formula also applicable for plane surfaces? Let us look at that. How we can apply this curved surface formula for plane surfaces. Let us drop down that curved surface formula here, n2 by v minus n1 by u equal to n2 minus n1 by r. So this we are given as curved surface formula. In this, r is radius of curvature, right? So r is radius of curvature. Then now, radius of curvature of plane surface. Are you able to measure the radius of curvature of a plane surface here? Suppose if you have any curved surface, for that we have radius of curvature that maybe you are taken as unknown value, something r here. So center to the boundary that we are given as r, as radius of curvature. Here simple to measure this r for a curved surface. Then what about plane surface? Here simply you are starting from a point. Then you are moving continuously, endless. So in this case, we will take radius of curvature of a plane surface is equal to infinity, undefined, unable to measure that. So we will take the radius of curvature of a plane surface is r equal to infinity. Then substitute that value r equal to infinity in the curved surface formula. Then what you will get? Simply here we will get n2 by v minus n1 by u is equals to n2 minus n1 by infinity. Substituted. Then here we know simply 1 by infinity equal to what? So here how to find out that 1 by infinity value? I will show you here. Simply we know 0 by something is equal to 0. 0 by something is equal to 0. Then what about something by 0 is equals to? Something by 0 is equals to infinity. Something by 0 equal to infinity. Let us transpose these values. Here this 0 I am transposing to right side and infinity left side. So what I can write here, 1 by infinity is equal to 0. Simple. Here infinity is taken as 1 into infinity. So 1 into something is equal to that something only. Or one more method is there. 1 by 0 is equals to infinity. Then writing reciprocals. 0 by 1 is equals to 1 by infinity. So 0 by 1 equal to what? 0. So 1 by infinity equal to 0. So that we will substitute in the relation. So n2 by v minus n1 by u is equals to n2 minus n1 by infinity will be 0. So we will write 0 here because 1 by infinity is taken as 0 by 1. That 0 by 1 is equals to 0. So n2 by v minus n1 by u is equal to 0 is the relation. So this formula is given as plane surface formula. This is known as plane surface formula. So maybe it is clear to you, everyone. Then let us move to the another topic of this lesson. That is here simply example problems, applications of a curved surface formula and a plane surface formula. Then we will discuss one interesting problem in the example 1. So look at that carefully here. The problem is given as followed. What is that? Here simply a bird is flying vertically towards the surface of water in a pond with constant speed. There is a fish inside the water. If the fish is observing that bird is exactly vertically below, the bird will be appear to the fish to be. So simple, break the sentences to understand about it. A bird is flying down vertically towards the surface of water in a pond. So I break that sentence. And one more here is there in the next sentence with a constant speed. Remember that. So here simply you can draw an image for this given information. So here I'm taking one area for this figure. Simply it is for bird flying vertically down above the pond. So below it has pond. So water surface completely it is a plane surface, or it is a plane surface. So here above the pond, bird is flying vertically down. Exactly below it, what is there? A fish is inside the water. Then when the bird is flying vertically down with a constant speed, a fish is vertically below it, and simply the fish observing the bird. So here the question is, bird will appear to the fish to be. So now the observer is fish. So this is observing. Then object is bird. So here we know when it started to observe, it is located at a particular or a certain height above the water surface. Will be located at a certain height. Then it appeared to the fish to be. Then here there are 3 possibilities to observe the bird. It may be exactly at same place or above the actual position or below the actual position. So there are 3 possibilities. Exactly at the same place, above the actual position or below the actual position. So here simply in the question there are given a few options. Farther away than its actual distance, or it is, if it is farther than its actual position, so the bird will be appear to the fish at this place above. It is far place. Okay, then next option is given closer than its actual position. If it is closer, the bird will be appear to the fish below the actual position. So let it be take that position below the actual position. So 3 possibilities are there. Exactly, above, or far. That means below. So far, below, or exactly. So 3 possibilities are there. Then here, if it is observed far, then what about its speed? Actually in the question given constantly. speed is taken constant, but fish can observe the bird moving with the faster or slower than its actual speed. So moving faster than its actual speed or moving slower than its actual speed, that we have to conclude. So here if it is far, what about the speed? If it is closer, what about the speed? If there is exactly at the same place, maybe it can move with the same speed. So which of the four options are true? Then how to prove that? So let us prove how it will be, right? So here simply we can prove it. We can prove it using curved surface formula, but apply that curved surface formula to the plane surface because the water body is plane surface. The water body is plane surface. So before going that formula, I will take the distance, object distance, original. So where is that? Exactly in the middle. The bird, three birds are given here. Exactly the middle bird is object for us. So let us take the distance of the object. Let us take the distance of the object from the water surface, plane surface. So let me take that distance as something x here. So the distance is taken x. Next, here, if that object is observed far from that, let me take that distance as unknown y. That I am taking as something unknown distance y here. Okay. The next, if it is observed at below, for that also I will take the distance y. Right? So here I don't know where the fish observe that bird appear to the fish, right? So maybe far or maybe below, right? So closer, whatever it may be, it is observed as image I or I dash. It may be I or I dash. So for the both images, I will take the distance is y here. Then if it is away, far, then we will get y is greater than x. If it is at an actual distance, I'll get y is equals to x. If it is closer, I'll get y less than x. So based on my answer, I may get y equal to x. Suppose I'll say exactly at actual distance. If I get y greater than x, I'll say far from that. If that gives you y less than x, I'll say it is below. So there are three possibilities. So let us see here, which is correct for that given information. So let us go for solution. So we are clear what is object, what is image here. So maybe the image is I or I dash, right? If it is I, then we'll get y is greater than x. If it is I dash, I'll get y less than x. So let us go for the solution here. So let drop down here plane surface formula. So what is plane surface formula for us? Here it is. Plane surface formula is simply n2 by v minus n1 by u equal to 0, because plane surface has its radius infinity. So 1 by infinity equal to 0. From that, I can write n2 by v minus n1 by u is equals to 0. Then, according to the assumption, we made an assumption, maybe far or maybe close. For the both, I taken the distance of the image as y. Object distance is x. So here, our distances parameters we can drop down here. That is u equal to minus x. applied rules of sign convention. So here, simple logic I will give you here. According to this, you can take that distances. Here, object side, negative, right? And another side, opposite side, positive. So where is your object? Where is your image? Both are object side only. Both are object side. So they are negative. Simple. According to that, u equal to minus x and v equal to object distance. Observer is below the water, right? Observer is below the water. So image, same side. Here we will take that image distance y is negative. Same side to the object. Okay. Next here, what you need, refractive indices. So here, where the light started, where is object? It is above the water level. So we will take the object distance from above the water surface. So that is first medium for us. First medium is air. So its refractive index, we will take it as here value something n1. So that n1 value here we will take, right? N1 value we will take as refractive index of first medium here. Refractive index of a first medium. Okay. Then what about refractive index of second medium? It is refractive index of water. That we will take it as unknown value something n2, right? Then here note down that values. Note down that values. N1 is refractive index of the first medium and n2 is the refractive index of second medium. Then according to 9th class knowledge, n1 value, that refractive index of air is 1.0003. So approximately we will take it as 1. Then n2 value is, according to 9th class knowledge, we have water refractive index is 1.33. But here taken as n. Later on, I will substitute the value as 1.33 here. Okay. Then I have the values. N2 value, N1 value, V value, U value. So all are available. Then substitute that values in the given relation N2 by V minus N1 by U equal to N2 minus N1 by R. So let us take that formula as it is. Then substitute the values. That is equals to, here N2 is N. Then V is minus Y according to the sign convention, minus already in the formula. Next, N1 is 1. N1 is 1 and U value is minus X. U value is minus X, substituted. Then simplifying these steps, that equal to already given 0. So don't take this left portion. Forget about this, forgot. Okay, what is remained? N1, N by minus Y minus 1 by minus X equal to 0. So here product of this negative sign, minus into minus, minus into minus, what will take? Plus. So what is remained here? N by minus Y is equal to, so I am transposing that, minus into minus became plus. So on moving opposite side, taken to be negative value. So minus 1 by X will be written. Minus 1 by X will be written. Then minus minus cancel here. Minus minus cancel here. So what is remains? N by Y equal to 1 by X. N by Y equal to 1 by X remains. Then take the cross product. Take the cross product. So what you will get? 1 into Y is equal to Y. Then n into x equal to nx. So I got y equal to nx. But what is our assumption? Y may be greater than x, y is equal to x, or y less than to x. But does not match, do not match to any assumption. What to do in this case? Simple, assume. Already I have assumed that n2 equal to n is taken to be 1.33. Then what about x value? let us take as 100% value, x is equals to unit value, that is as 1. Then what you will get? So here simply I am going to assume the value of, right? Value of. So n equal to 1.33 and object distance x equal to 1. Then image distance y is equals to, image distance y is equals to n into x. N is 1.33, right? X is 1. Then what will be the value of y? What will be the value of y? That is 1.33. So automatically I can compare the value of y with x. So I got y is greater than x. Y is greater than x. So simply what I got? Y is greater than x means y is image distance. So image will be formed farther than its actual position or actual distance. So from the assumption which are correct here, I is correct or I dash is correct? Y is greater than x is correct, or y equal to x or y less than to x? So from the assumption, simply I got I is correct. I is correct. So remaining wrong. So this is the solution for the given problem. Y is greater than x. So the image will be formed farther than its actual distance. That means the fish observes the bird, or bird will be appear to the fish farther than its actual distance. So option 1 decided as correct for this question. Then if the bird is appear to the fish farther than its actual position, suppose I am observing this from outside of the pond, just on the shore. I'll myself lying on the shore observing this bird, but the same bird will be observed by the fish at this distance. So from the shore I am observing this bird is moving with a constant speed closer to the pond surface. Then the bird is observing farther. Then according to me, the bird reaching the surface at a certain time t. What about the image? Will it reach the surface or remains above the water surface? Never remains. Here, suppose imagine your shadow behind you, right? And you are walking towards the light, opposite to, towards the light, facing opposite to the light. So your shadow will be backside. When you reach very close to the light, what happens? Your shadow size increases. Okay. Now assume that vertically, just angle, slightly angle, you are coming towards the light. Your shadow size increases. Just if you come vertically below the light, where will be your shadow? Exactly reaches to bottom. Will not remains at any place. So that shadow moves faster than you to reach same point, right? So like that, the bird and images reach in same time. Reach in same time. So here I have formula for time having the different velocities. So what that is, here look at velocity equal to displacement by time, or speed equal to distance by time. So anything you can imagine here. Okay. What about time equal to here? Time equal to distance by time. Transposing here, distance by velocity we will write. Okay, written. Then simply now come to the topic, bird moving with a constant velocity. With a constant velocity, suppose taking is 1. Then what about this? For the distance, will it take time more or less? So here more distance, more time you will get. If assumed with constant speed, image also with constant speed 1, what happens? Here you will get t equal to x and t equal to y. Is this correct? If it is correct, image will be remains above the water level. Is it possible? No. The bird and the image will reaches water surface at same time. That means the image will move faster. Then it's a actual speed. So here simply the answer is A and C. Faster than its actual speed. So this you have to do logically, mentally, right? Then only you are able to answer for this question. So this is solution for the example 1. So let us move to the example 2 from this. So what is here example 2 is? Example 2 is simply, it is about observing a transparent sphere having the radius r. So here a transparent sphere of radius r and refractive index n is kept in air. At what distance from the surface of the sphere should a point object be placed on the principal axis so as to form real image and the same distance? Image is at same distance from the second surface of the sphere. So just you have to draw figure. So here a sphere is given with the radius r. So transparent sphere is given to you. So this is the transparent sphere. Okay. Its radius is given. Its radius is given. So from the center to the boundary, that distance we will take it as its radius. So radius is given as r. Then draw a line passing through the center. That we can take it as here principal axis. Right? Here you are able to imagine it's a pole. Okay, it's a pole. So the line connecting or joining, passing through the pole and center of curvature is given as principal axis. Okay, we have the principal axis. Now, simple. Go for your question once again. Here radius of curvature of the sphere is given as r taken and its refractive index is given as n. Then object is placed at a certain distance. Do you know that certain distance? No. So imagine that point size object is kept at a certain distance from the pole. So that distance, assume something unknown is taken to be x here. So x distance is assumed for the object distance from the pole at a point O. Then where will be the image formed? That is already given at x distance, at a x distance. So here simply from the point O, you need two light rays to trace its image. So one is making angle with the principal axis and the other is exactly along the principal axis. So one is taken making angle with the principal axis and instant that light ray on the sphere at a certain point. So here we know refractive index of the surrounded medium is n1 and the refractive index of glass sphere is n2, but that value is given as something unknown n. Okay, we'll take it later. Then next, here construct a normal to the point of instance. Then what happens? Rarer to the denser, light propagating from air rarer to the medium called denser sphere. So what happens here? Rarer to denser bends away from the normal. So here simply angle of incidence. Then we will measure angle of refraction. Rarer to denser towards the normal. Rarer to denser towards the normal. So here angle of refraction will be smaller. So bends towards the normal. Okay, so here trace the light ray path in the sphere, refracted light ray. Then it reached other surface. Again, you need normal to that point of incidence on the second surface. Then here it bends away from the normal, so meets the principal axis. So I got that light ray going to meet principal axis. Then I need second ray that is along the principal axis. So the light ray passing along the principal axis remains undeviated. The two light rays are going to meet each other at a certain point to form the image. That image is I here. The point of what are two light rays coincides each other, refracted light rays taken to be image point I. Next here, I obtained image. In the question, it is given the image is formed at same distance. So here image you can take, right, from the second surface at same distance because equal radii. Okay, why we are taking like that, I will give you explanation. Okay, here the image distance is also taken to be same, x distance, right? Then how to solve this one? So here simply I am making this into two parts. Making this into two parts exactly at this spot, center. So here look at this figure again. If I consider this is a object after first surface, incident light ray and these refracted light ray and principal axis are becoming parallel to each other. So where will be the image obtained for these two refracted light rays? At infinity. Okay, in the second surface, light rays are parallel and incident on a concave surface. So light rays parallel, in which case we will consider when the object is at infinity. So U is considered at infinity distance. Then where will be the image? At x distance. So for the first surface, image is at infinity because after refraction the light rays are becoming parallel to each other and object distance is U is equals to x. U is equals to x. For the second surface, object distance is infinity and image distance is taken to be x. So this you have to understand. Then we'll go for the solution here. In the solution, note down the values you are obtained here and substitute in the formula. Which formula we can consider? You are dealing with the curved surface. So curved surface formula you need. What is curved surface formula here? N2 by V minus N1 by U equal to N2 minus N1 by R. As per symmetrical figure, because here symmetrical figure only, making into two equal parts and having the parameters same. So that's why it is said to be symmetrical figure. Okay, so here as per that symmetrical figure, the rays pass through the sphere parallel to the principal axis in the sphere. They became parallel. So in such case, what we can consider? Object distance for the first surface is taken to be x. So according to the sign convention, given is negative, opposite to the incident light ray. Next, here image distance will be taken infinity because the light rays after the refraction became parallel here. So that is the reason image formed at infinity distance because rays became parallel to the principal axis. Then what about the refractive indices? We know N1 and we know N2. N1 is refractive index of the air. So let's consider that value as 1 here. And N2 value is N here. N2 value is N here. Okay. So simply I will take that distances here. So sorry, refractive indices. N1 is 1 and N2 is N. N1 equal to 1 because air is the surrounded medium, refractive index of the air. The next, N2 is the refractive index of the sphere. Unknown value is given N. Then we know the four values. What about radius of curvature R? It is negative or positive. So look at that. Incident light ray towards right side and the radius of curvature measured between these two. So measuring pole to the center. So taken to be positive. Taken to be positive. So here simply you will give the value of R with positive sign. With the positive sign. So plus R. Then here substituted the values. Here simply N2 is N taken and V equal to infinity substituted minus 1 by U is minus X substituted. That equal to N2 is N minus N1 is 1 and R equal to plus R. All the values are substituted. Then what about this N by infinity value? So we know 1 by infinity is equal to 0. 1 by infinity equal to 0. So what is remained here? Minus into minus plus 1 by X. So 1 by X equal to N minus 1 by R. Actually, what you are trying to find out? What you are trying to find out? So is to form real image at the same distance where the object will be placed. Right? At what distance from the surface of the sphere should a point object be placed? So this you are finding. So already we assumed object distance is X. So I got 1 by X equal to. So write reciprocal, you will get the answer. So X is equals to R by N minus 1. So this is the place you are selected to put the object and to obtain the image at same distance. So here object must be placed on the principal axis from the first surface is at a distance called X is equals to R by N minus 1. So this distance you will select. You will find out this solution by using the second surface also. Simple. According to second surface, let us substitute values here. According to the second surface, here object U is equals to infinity and image distance V is equals to plus X. Then first surface is sphere, first medium is sphere. So N1 is equals to now N and N2 is air. N2 is equals to 1. N2 is equals to 1. So substitute these values. N2 is N by V is, now it is taken to be plus X minus N1 is, N2 is 1. Sorry, I made a mistake. N2 is 1 by V. V is plus X minus N1 is N and object distance U is infinity is equal to N2 is 1 minus N1 is N by R is here simple pole to the center opposite to the incident light ray. So we will take negative minus R. So this term will become 0 because 1 by infinity is there, 1 by infinity equal to 0. Then look at clearly here, denominator has minus. So convey that to the numerator. So here you will write minus 1 and plus N after simplifying that. So this will be written as this will be written as, no, sorry. No need to change that. Just convey to the numerator. No need to expand. Here what we'll get? Minus 1 minus 1. Not getting object distance is infinity. Image distance is positive. Okay. There is no mistake in this. U is equals to and V equal to. Okay. Take comma. Expand it. So minus 1 and plus n by r I got. That will be written as n minus 1 by r. This is 1 by x is equals to. This is 1 by x is equals to. So what we can write, x is equals to reciprocal. So from this, if you are writing reciprocal, x is equals to r by n minus 1. So got the same result using the second surface. So using any surface, you are able to find out the solution. So this is the method you need to follow in solving this problem. Any surface you can consider, only one surface, right? Then inside the sphere, the light rays are becoming parallel. Sir, how you know they are becoming parallel? Because you don't know angles. Here the condition is that given object distance and image distances are same, then here simply the rays are symmetrical. Otherwise, you won't get the image at same distance. So that angles must be same here. This angle and this angle. Here inside this angle, these angles are same. Otherwise, it is impossible. So that is the logic here. That's why we are taken parallel rays. So this is example 2. Now we have example number 3 here. Example number 3 is simple. It is given about same curved surface only using a sphere. A transparent glass sphere has a small opaque dot at its center. Does the apparent position of the dot appear to be the same as its actual position when observed from outside? Understand the question first. We have a glass sphere, transparent, and observed from outside. What we are observing? Opaque dot, which is located at its center. So here object is located at the center. So here I connected that object or the center of curvature with the boundary. So that will give you what? Radius of curvature. Radius of curvature. So simply here I am observing that opaque dot from outside the sphere. Then apparent position of the dot appeared to be the same as actual position or not. That we have to decide. So we have to find out what? Image distance, because we are observing the image of the dot, which is inside the sphere. Object located at the center of the sphere, and you are observing the image of the dot, which is located at the center of the sphere. But is it observed at same distance or at a different position? That you have to decide. So where is the object? In the sphere. So which is first medium? Sphere only. So sphere refractive index I am taking as n1 and surrounded medium refractive index as n2. n2 and n1. So n2 is refractive index of the air and n1 is refractive index of the sphere. So let us take the refractive index of the glass as n1 is equal to n now. n1 is equal to unknown given as n. Then what about refractive index of the air medium here? n2. That is, according to our 9th class knowledge, 1.0003 approximated as 1. So I got the n1 and n2 values. Let us know the values of object distance and radius of curvature. So object distance is unknown. That is given as r equal to the radius of curvature because it is located at center. So object distance u is equals to unknown value given as radius of curvature minus r, because here minus y I am giving, I am measuring, sorry, it is opposite to the instant light ray, pole to the object. Okay, here not located that pole, I am showing you the pole here. This is, so pole to the object is object distance, instant light ray is left side, and measuring direction is towards right side. Measuring direction is towards right side. So that's why I am giving that object distance is negative. Object distance always negative. U is equals to minus r is given. Then what about radius of curvature? Also measured opposite to the instant light ray. Opposite to the instant light ray. So radius of curvature is taken to be negative. So instant light ray towards left and measuring radius of curvature towards right. Pole to the object, pole to the object, pole to the center. According to rules of sign convention, all the distances must be measured from pole. So that's why I'm giving you negative. So u is a negative, r also negative. Then what the surface we have here? Sphere. So it is curved surface. So what the value we can take? That means formula. It is n2 by v minus n1 by u is equals to n2 minus n1 by r. Let us use the curved surface formula here. That is n2 by v minus n1 by u equal to n2 minus n1 by r. Then drop down the values. Here we know n2 value. N2 value is 1 and n1 value is n. Then v value is unknown, we are finding. So let us drop that value of v. I same as is v only, minus n1 is equals to n substituted and u equal to minus r substitute that is equal to n2. N2 is 1 and n1 is n, 1 minus n by r. R is minus r now according to sign convention. So r is minus r substituted. Then I want v value. So that v term only remains at left side. Then remaining you can send right side. So minus into minus plus. So what I can write? 1 by v plus n by r is equals to 1 minus n. Okay, here denominator has minus. Denominator has minus. So we will convey that to the numerator or expand it separately. So easy one. So expand here, simply expanding means you will write 1 by minus r minus n by minus r. So here minus into minus will be written as plus. This minus r as is taken. Then see the terms plus n by r plus n by r. They will be cancelled here. They will be cancelled here. So simply you can cancel it. N by r cancel. Then what is remaining? 1 by v equal to minus 1 by r remains. 1 by v is equals to minus 1 by r or 1 by minus r. No problem. Then writing the reciprocal, what I will get? V equal to minus r. V equal to minus r. So here r is the image distance. What is our radius of curvature? So where it can be located from the pole? All the distances measured from the pole. So from the pole, you are measuring image distance. So the direction is negative, means opposite to the instant light ray. Instant light ray direction is towards left and we have to measure right because opposite side. So r will be measured towards right. So where the image will be obtained? At same or another position. So at the same position, the image will be observed. Object distance is equal to image distance. So here simply that opaque dot will be observed at the same spot, at the center, at the center. So this is example 3. So these are the applications of a curved surface formula and plane surface formula. Curved surface formula and plane surface formula applications are complete. Then in the next class, we'll discuss about the lenses in the next class. So thank you. I think this explanation about the problems are very clear to you. I hope you enjoyed this class. So if you are really like this class, just comment your feelings, opinion regarding this class, and also try to share this with your friends. Thank you. We'll meet in our next class with the topic lenses.